1.1 is about the Pythagorean theorem and its converse. So first we're going to look at the Pythagorean theorem, and that's right down here. And you can saw from the solve it that when you put two squares together, it equals the third side or third square, and we can rewrite that in terms of the sides. So one side squared plus another side squared would equal a third side squared. And so from this Pythagorean from this Pythagorean theorem, we can come up with, when we're dealing with a right triangle, this thing called a Pythagorean triple. So what a Pythagorean triple means is when we have three numbers in here and we square all those sides, we square those numbers. When we add up two of them, it will equal the third. Okay, and that will create a Pythagorean triple. So one of the famous ones, or the first one, is a 3, 4, 5 triangle. So if I have a triangle with 4 and a side of 3, and I square those numbers, well, it will equal my hypotenuse. Hypotenuse is always across from the right angle. It will equal that side squared. So 3 squared is 9. 4 squared is 16. And 5 squared is 25. And 9 plus 16 is 25. So this is a Pythagorean triple because these sides, 4, 3, and 5, they fit the Pythagorean theorem. So whatever three numbers, you can add up square the two smaller ones and add them together. And if that equals the third side squared, then it's called a Pythagorean triple. So that's what creates the Pythagorean triple. Okay, and so let's go ahead and look at our problem number 1 here. So problem number 1 is finding the length of the hypotenuse. So we want to use the Pythagorean theorem to find our length of the hypotenuse, and the hypotenuse is always across from the right angle. Okay, so I'm going to go and I'm trying to find this. Usually always the hypotenuse is labeled C. So you notice we have our angles here with all capital letters, and the sides across from them are always the lowercase. So that's why this is a C. Okay, so I'm trying to find out what C is, and I'm using the Pythagorean theorem. The Pythagorean theorem says A squared plus B squared equals C squared. And the A and B just relate to the smaller two sides, and C always relates to the hypotenuse. Okay, so I want to take my smaller two sides, so that's 20 squared and 21, and I'm going to square them and C to find C squared. So here I'm going to have to do some algebra, right? 20 squared is 400. And 21 squared, that's just 442. So 21 squared is just 442. Or 441, sorry, 441. And I'm going to add those together, so that's 841, and that equals C squared. But I don't know what C squared is. I'm trying to find C. So how do you get rid of a squared? Well, we just square root, right? So I'm going to take the square root of 841, and I'll see what I get, and I get 29. So C equals 29, or I can reduce that, right? If I don't get a perfect number here, I can reduce that. So there's my C. So what is the length of the hypotenuse? Well, the length of the hypotenuse is 29, and it's always going to be the positive, right? Because when I square root, remember, I get positive and negative answers. But here, since I'm talking about distance, it's always going to be positive. All right, so we have our hypotenuse. Now do the side lengths of this triangle ABC form a Pythagorean triple. Now, because this came out to a perfect number here, a whole number, that means it is a Pythagorean triple. Yes, Pythagorean triple. Okay, because my 20 squared plus 21 squared equaled 29 squared. Because 29 squared is 841. Okay, now go ahead and use these two numbers, 10 and 24. So those are your two smaller sides, 10 and 24, just like 20 and 21 was. So go ahead and do that one. And that is how you find the length of the hypotenuse, is using the Pythagorean theorem. And you can test if it's a Pythagorean triple to see if you get whole numbers for your C. Okay, so that's it for problem number 1.